All right, so 9.3, we are looking at solving quadratic equations. So the first thing with solving a quadratic equation is that it must be in standard form. So remember, our standard form for a quadratic equation is ax squared plus bx plus c. The important part to add here is that when we are solving a quadratic equation, we must set it equal to 0, right? The only other details to remember is that in order for it to be a quadratic equation, that a cannot equal 0. The next thing we have to look at here is the y-intercept. Just a reminder, the y-intercept is the point or points where the graph crosses the y-axis. Okay. So that means that the x-coordinate must be 0. All right, when solving a quadratic equation, we will find something that we call roots. So roots are either the x-intercepts, the zeros, or the solutions of a quadratic equation. I should have probably specified roots are all three of these things. So we have a couple different types of solutions that we will see. So the first type of solution is when we have a quadratic that is located above the x-axis. In this case, we would have 0 solutions. This is because our parabola will never cross the x-axis, which where it crosses the x-axis would be our solutions. In the case where, maybe our parabola is facing downwards and it crosses the x-axis twice, or maybe it is facing upwards. Oops, I'll try that one again. Facing upwards and crossing the x-axis twice. That is the situation where we will have 2 solutions. And then the final situation is when your vertex is located on the x-axis. That would give us parabolas that look like these. When your vertex is located on the x-axis, that would give us 1 solution, which would be considered a double root. Okay. So when solving for zeros, or ax squared plus c, where b would equal 0, that means that we would want to isolate our x squared on one side of our equation. Then we would take the square root to undo the square. This would give us our 2 solutions. So remember, you can only take the square root of positive numbers, and taking the square root will result in 2 different answers. Those answers will be either positive or negative. Okay? That means that when you take the square root, you will have to have plus or minus whatever your solution is. All right. On to page number 2 here. So in page number 2, we have a couple of examples. So in my first example, if I was to take, let's see, I have x squared minus 4 equals 0. First thing I want to do is isolate my x squared. So I am going to go ahead and add 4 to both sides. Okay, that's going to give me x squared equals 4. Then, to solve for x, I'm going to take the square root of both sides. That's going to give me x equals, the square root of 4 is 2, but remember, when you take the square root of both sides, our solution is going to have plus or minus. Okay, that would give me 2 points on my graph because I know that when y equals 0, my x is going to equal either positive 2 or negative 2. So my two ordered pairs would be 2 and 0 and negative 2 and 0. So I could go ahead and graph those 2 points on my graph. And ultimately, it would give me a parabola that looks something about like that. Okay, similarly, I could solve my next equation. Start by subtracting 4 to both sides. That's going to give me x squared equals negative 4. So then, to solve for x, I would have to take the square root of both sides. But in this case, I'm in trouble. Since I'm taking the square root of a negative number, that means that I will not get a real solution. So what you would write is no real solution. Okay, that means that your graph is going to look something along these lines because our parabola will never cross the x-axis. In the final example here, we are going to get the other type of solution. So start by subtracting 3. That's going to give me 5x squared equals 0. Then, if I wanted to solve for x, I could divide by 5, which would give me x squared. 0 divided by 5 is just 0. Square root of both sides. The square root of 0 is just 0, so I'm going to get x equals 0. And that's a singular answer because plus or minus 0, it's the same. If I wanted to make a graph for this, I don't know why I don't have a graph already made. This is one of those cases where I'm going to get a double root. So it would look something along these lines if I was just to sketch it. All right, so that's all 3 of our possible solutions in action there. So the next thing here is the zero product property. So the zero product property says that if we were to find 2 factors, we could set them equal to 0 to find the solutions of both of those products. What would make both factors 0? So in a case like this, I could take my first factor, 4t plus 1, set it equal to 0, and I could solve for t. So I would subtract 1 from both sides. That would give me 4t equals negative 1. Divide by 4, divide by 4. And that would get me my first solution, which would be t equals negative 1/4. Okay? I could also do the same with my second factor. T minus 2 equals 0. In this case, I would add 2 to both sides, which would give me t equals 2, which would be my other solution. If I wanted to, I could write this in set notation, saying that t equals negative 1/4 or positive 2. Okay, so pretty much if you were to set factors equal to 0 and solve out both of those factors separately, you could find your two solutions for your variable. Okay, I'm going to leave the other examples for class. We have already kind of gone over this in the past, so we should be good to go. All right, very last thing here. Actually, I think that is kind of it for this lesson. So I will leave these two for class. Give them a try on your own. They're already in factor form, so it's totally saving you a step. And then in 9.4, we will look at factoring and then solving. All right, thank you guys for watching.